First block. This is the first block. So similarly, anything coming from here, this is the second block. So coming from zero, 17 block is there. So people say maybe 16 row and 16th block. Blocks are like this. 16 will be 16 there. That is not possible. That means zero. And that's what I do. Because what you have done, they have the money for approach. You have done, they have money for approach. Now we give someone for Seismic expertise.
मिल गया
So this is basically so G I G represents water. So it is a ray coming from source I and crossing the J property. So suppose this is our grid. This is 16 by 16. So G1 18 means is coming from the first and crossing the 18 point. That is the interpretation. So I can
इधर से
So इसका मतलब ये है, suppose on the blue you are basically zero. So there are some that is zero. So 99 So this is space. So when you go, this is structure. This is system. So seems to you. So comes in.
yeah, this is the same.
This is the initial system.
Okay, so there was a question about the geometry, right? So we have So we have 16 sources and 16 receivers, right? And the grid here is 16 by 16. So your model parameters are going to be 256. So you go to D equals GM. Then your D is your 256 because you have 16 source times 16 receiver, right? And N is basically 256 because we have 16 by 16 grid, right? So many variables, and therefore your G is 256 by 256, okay? So it's a square matrix, but still it won't invert because of rank deficiency. Okay, does that answer your question? So my plan is you should stop around 10:30, 11:30, and then I will ask each group to come up here and show me what you have done. And at the end, I can show you my results, okay? Both. No Tikhonov, just the first one. And also, if you have done your least squares and a linear regression, if you have any doubts, you can ask, but probably you don't have any doubts on that. But okay, if you don't think you have a good answer, don't feel bad because I will tell you, what needs to be done later on. But I just want to make sure that you have followed the steps, okay? Once I give you the answer, you already know what to choose, right? But as long as you have taken right steps, that's what is important. Okay. And whenever you come, you can share your screen here and then let everybody see what you have done, okay?
This is an associated nature. This is the analysis associated with Oh.
Yes.
So this one we have grid cells in between. Then the values that are provided in those grid cells, those are is it M or D? Those are D.
No, D is D vector has this, and G has essentially your distance to the each block, right? Because the way it works in tomography,
Units, when you tell the units of each of those, what meter per second or time.
D is time, M is slowness. Okay, so this will be like yeah.
So how do you measure the time? How do you measure the time here?
So we measured the ray path length.
Okay, so suppose we know the time there and there. So these are the geophones.
Right.
So we know when it was fired, when we received it.
So you assume that this is a straight ray path, and then you know so you have this grid, right? Let's say that you have a short here and you have a receiver there. If you draw a ray, then you know the length of the ray in each one of these. Okay, in some cases it is approximate. Okay?
So my question, it might happen that there is right cost. This is track.
Yeah.
Now the range balance scheme is two blocks to very fast. And then two blocks to very slow and then again. But when we actually sort of uniformly.
Yes, so but that is why you have a lot of rays, right? From there you can yes. But you're absolutely right. If you have just one ray, you can have a system very good estimation.
So this one, just one more. This one.
values of the so the interpretation of this value and the interpretation of so we have
Depends on the
Geo-Elect. Respecting about same means that different ages.
but we are evaluating the different, everything is different speed.
Geology continues to be different. Yes.
In my perspective, how does it
Say you are this is number one, this is number two, then this is number three.
So this is the solution. No, this is the G matrix and this is the
So you get
solution. Using standard list. So this is here. And so to say, what is the so that's part A. Same. So 100%. That's too slow. It's too fast. This knowledge and the wrong place to 30 to 40 minutes. Should be 60 to 80, 40 to 80 seconds. It's just one. It's too far. Direct formula which so important this was given. We find this type of this is given Again, 5 minutes to go. Celestine SQ. This function basically uses SQ.
5 minutes to go. And what I want you to do is each group should come here in turn and then present the results. I'll call the groups at random. Okay?
So full time. Condition.
Group D, get ready. Okay? Who's group D? Do you guys remember what group D is? Okay. So you need to come up in 5 minutes. So the tasks are the following. First, you need to just show that regression notebook that you have run it, which is really not a big deal. And then you want to show what you got in terms of results with the exercise that I gave you. You don't have to have a good result. What I want to know is what are the steps you have taken, okay? Okay, group D, you can start to set up your laptop because that takes a little bit of time. Okay, group D, come up stage. And hook up your laptop. Okay, all team members should be here. All group D team members. but only one laptop. What happened? It's not connecting. क्या हुआ? Why don't you? Okay, Group B. While they're trying to fix it, let's see if Group B's laptop connects. Okay, Group B. Group D, go back to your seat. Maybe we'll call you later. Okay. Group B. What happened? Dinner? Are? You are B. Oh, okay, here you go.
वहाँ से कुछ मत कीजिएगा, वहाँ पे सोचिए
This is HDMI, right? Should be. हाँ PowerPoint है क्या? उसको एक कैसे करे को आ रहे हैं. No, I know you're not presenting this, but can you go to HDMI? Asse. So this is your. Yeah, VGA is not connected. This is HDMI. You know, this. Just get the screen back up. Okay, this is dark now. Go ahead. This is no signal. Yeah, it looks like there's something there. What is this? Wait, I think something is coming. Yeah, isn't it? Okay. काफी स्लो है. Whose machine is this, Dr. Soman Maiti? Are you connected to HDMI? No.
Using the standard list,
we try to find G and the M, right? So as you can see, first
You try to find M. M is the answer.
M is the answer.
Yeah.
So as you can see, we are first loading the G matrix, which is a sort of a flattened matrix in a columnar structure, and the D matrix. And we try to print the shape of the G and the D matrix, right? Right. So we try to print the G and the D shape. So it was coming around, it's coming 65536 and the D shape. So we tried two approaches to reshape the G file. One was the default Python, which is the row wise. So in Python, like, you have, suppose you have a matrix. So the rows are stacked. You take one row, stack it in a column, second row, stack below it, and stack below it. So we tried that approach, but then it was not coming out because the determinant was coming 0. So then we try to stack it column wise, which is the default option in MATLAB and R. Right. So we try to shape it the column wise. So for example, you have the first column of the matrix, and then the second column put it below the first, and the third below that. So we got it reshaped, and we tried to print the plot the G matrix. Right? So this is how it looks like, and I've also saved the G matrix in a file also. Okay, now so here you can see that I'm trying to find out the similarity of the matrix, and still the similarity was coming very high. It was coming infinity. So that shows that the matrix is very unstable. The condition number is also very high. When we try to print it, the condition number, which actually measures the stability of the matrix, is coming something like 10 raised to the power 18, right? So that actually gives us a hint that we might have to use SPD so that we can eliminate some of the very
Smaller
eigenvalues, right? So there is a function in Python that is the least square. So that actually inherently uses SPD in the background, and it has a parameter called R condition, and where you give the singular values cutoff. So if you give that cutoff, then all the singular values less than that it removes. Then it calculates that. And one thing I want to mention that we try to do with the direct formula, that is the G transpose G inverse. That did not work because the condition number is so high that the inverse, it will be very unstable. So by this approach, we got the M matrix, and we plotted the M matrix. It's something like that. I'm really not sure whether the values are correct or not. But
So this comes as a vector, but you have to reshape it into a matrix and then plot it.
Yeah, it's actually coming out like this only.
Yeah.
So I'm just plotting it.
Right, but you have to reshape it into a 16 by 16 matrix
I see.
and then plot it. Then we'll know if it's correct or not.
Fine. So
Okay.
we'll do that.
Okay.
That's approach.
Okay, good. And your name again? Shekhar. Okay. I'll explain to you later on. You are group C, right? Okay. Group A. I hope your laptop works.
Yeah. Scam. Okay. Can you zoom out? Yeah.
Just to show, since we had to show for the linear regression. So this is the other linear regression which was discussed yesterday. So yeah, I'm audible. Yeah. So there is some warning coming in this, so that is not very much concernable. So we have run it completely, and we have also tried to change the iterations since it was giving like iterations are less, you should increase. So we tried to work on that. So now coming to the main point for the assignment that was given. So what we tried is two things which I want to mention before we continue with the code, right? So if we see over here, so maybe I can zoom. So what previous group was saying, like what sir said, basically if he does it directly inverse, so it doesn't solve. It gives a singular matrix. The problem with that is since this reshape in Python and in MATLAB, they work differently. In MATLAB, it is working like column wise. Suppose I have 1 by 256 of matrix. So if I want to fill 256 values in a matrix, so it will fill column wise. So first it will fill the first column, second column. But in Python, it fills row wise. So when it is a row wise filling, so it becomes a singular matrix. That's why we are not able to solve it directly, which maybe they might have faced. So what we can do, we can just do a simple modification like order equal to f. We can make and it will fill column wise. So that way we can handle that problem. So what we did initially was we have loaded the G matrix in the D matrix that was given to us. So here we reshaped the G matrix into 256 cross 256 in a column way. So then we try to solve G transpose G over here. So basically the at the rate like dot T represents transpose. We can write transpose and bracket as well. Other thing is at the rate represents matrix multiplication. So similarly we have made two variables. One represents the G transpose G and the other one represents the G transpose into D. So when we go for simple least square inversion, like which can be done like in a way np dot lin alec dot in inv. So we do inversion for the G transpose G inverse and then we multiply it with the G transpose D. So we get something like this. So this is a very simple least square inversion. But what the other group included was the SVD. So we can include SVD as well is if we change it to np.lin.lstsq. So we also tried with that. So when we do with it, so we get a better solution because it is removing this based on single value.
So they found gas, huh?
So
That was the thing. Okay.
yeah. So we have plotted it.
Good
in
job.
a way. So next, when we go for the damped one, so just only the difference is we have to include while inverting, we have to invert like GTG plus lambda square and then whole inverse into GTD basically. That is the only difference. So when we see the solution for this, so this was for SVD, the first one. When we see for different alpha values, if we go for very higher alpha values, it goes away like this.
But this is exactly the point. Okay.
And when we even go for very low values, actually we were trying to do it, we were trying to plot it together. So if you go for very low alpha values as well, it also goes away. So we need to choose optimal value, which for us, I think will be coming around 0.01 or something near to that. So this is what we have done.
Good job. Your group one, right? Your group one. One, right? Okay, group two. Oh, group two laptop didn't connect. Okay, group three, did you try or not? Group three. Oh, you were already there. Okay, group four. Group four. Good. Okay.
assignment problem? Or?
Yeah, you can go directly to the assignment problem.
So the same way, like here in the question, we have loaded the vector data which was already given, and also we have loaded the matrix data also which was already given. But in the question, like it was said that 0.5 standard deviation is observed in the observation matrix. So for that, we have added the noise with respect to that standard deviation to the observed values which were already given, and that was taken as a vector form, vector matrix. And the same were others were also mentioning that the inverse in the Python is like along the rows and columns. We also did like along the column wise, and we changed that. And we did the transpose, and we calculated here the transpose is the GT which we are talking about, and the multiplication is the transpose multiplied by our G vector G matrix, and the next is the inverse where we are calculating the GT G transpose multiplied by G that inverse, and that product is the inverse multiplied by again G transpose, and the result we are giving it as that product multiplied by our D vector. So that result we are able to see like at the bottom, and so this is of with respect to the reshaping thing. So in order to with regularization with weights, so what we have done is we have randomly chosen different weights of 100 weights. So from 1 to 10, like we have randomly generated, and the same thing which was done earlier. Like we have added one term called regularization weight multiplied by realization, so that we have kept in a loop so that it will take one value at a time and do the process every time. And we are assigning that particular result to a velocity regularization matrix which has 256 rows and 100 number of columns. So one column will have a result of one with one lambda value or alpha value. So like that we populated for 100 values. Okay. So yes, we are plotting them. The second plot gives us the x and y along the direction.
Good. And all you have to do is to flip it. So your results good. Okay. Okay, good. And your group? Oh, group D. Okay, so I was going A, B, C, D, and I want to 2, 4. Okay, so which group is left? No. Group B. Okay. Okay.
So, sir, first of all, we created a square matrix from the G matrix. It is a 256 by 256 matrix. And after that, I have tried with the simple inverse of GTG, and we are getting that it's a singular matrix. So from this singular matrix, we are not getting the inverse of GTG. So that's why you use the SVD to create the inverse of pseudo inverse of GTG, and we calculated the simple least square, and
Can you bring your microphone close to your mouth so that everybody can hear you?
this is the result we are getting
Okay.
with a matrix F of 256 column matrix. And for the calculations of optimum alpha, we use that the eigenvalues of GTG, 10% of that. So, and using this, we are getting a matrix this one, sir. Like from the 10% of the eigenvalues of GTG. And
Have you plotted those? Yes.
yes, sir. And this is the plot with the 10% of GTG. And then I have used the different alpha, like from 0.01 to 10,000. And this is the plots we are getting.
Okay, so you are on right track, but I think there may be some mistake somewhere. So you can talk to the other group and see what the problem is somewhere in the code. Okay, but definitely good effort. Okay. Okay, which group is next? Sabkaniwa. There was more than 4 groups. Which group is your group? But we have to call out. And those who have not presented, please come forward. Ankit, your group? Oh, you were in group A. Okay. Yeah, come. Group 4. Okay. And Gautami, where is your group? Oh, you can connect it to the power there. Okay, if you don't want to present, that's fine, because all that matters is you need to interact with the other groups and get their solutions and practice with that, okay? And you have the basic ideas clear now, right? That if you just take the matrix and invert it, it's not going to work. So you have to add some clamping, that is called regularization, and that is very, very important, okay? And so that should be it. And then in the afternoon, we'll have a lecture, and then we'll go from there. So group A, and which other group got gas? Who else found gas? Group A and Group C? Group A and Group D. Okay. Now you're able to find, right? Now everybody should be able to find gas, okay? That's why I made this up, so don't worry, because the first time I prepared this exercise and gave it to my class, there was they just revolted, because says, no, you cannot. I gave it in the midterm exam. And after the exam, I had like 30 students. They were about to kill me. So don't worry. But it's a very important exercise. Through this, you learn the importance of regularization, and which is something that you're gonna be using in almost every application. Okay. Okay. Good. So we break for lunch now, right? 12. Any question? You guys are awfully quiet, so I don't know if you are really following my lectures or not. Okay.